In this video, I'm going to go over a problem on how to simplify resistive circuits. However, before we begin the problem, let's review the rules of simplification. The first rule is for combining series resistors. For two resistors to be in series, that means that they share the same current. And to find the total combined value, all we have to do is add the sum of the two resistances. Now, for parallel resistors, instead of sharing the same current, they share the same voltage, meaning they have the same potential on both sides. Now, combining parallel resistors is a little more involved than series resistors. One way you could do it is through this nasty fraction. However, you can algebraically simplify that into this form, which is a little bit easier to work with. So now that we've gone over the basics, let's begin the problem. The first question when beginning resistive circuit simplification is, from where are you simplifying it with respect to? Sometimes this is going to be labeled on your circuit, other times it's implied because you're given something like a voltage source and you want to find the equivalent resistance seen by that voltage source. When doing these kinds of problems, one tip that tends to make this easier is try to focus on the resistors furthest away from the voltage source. So for instance, if we look at the corner over here, we can see that these two are in series because if there was a current flowing through the 150 ohm resistor, it would have to continue through that 600 ohm resistor connected to it. Being that they're in series, we can add up the total resistance to find the equivalent, and that's going to be 150 plus 600, and that's going to be an equivalent 750 ohm resistor. So I'm going to go ahead and erase these two, and I'm going to draw in my 750 ohm resistor. If we look at the other side, we see the same situation where we have two resistors that are sharing the same current. So that means we can add them up and find the equivalent series resistance of these two. So 750 plus 250 gives us a total resistance of 1000. So let's erase these two. So we can draw this in. This is going to be 1K. Now at this point, I notice that my two 1K resistors have the same potential on both ends. They're connected with a wire between each other on both ends. So that means that they're in parallel. So I can calculate the total resistance between these two as 1000 times 1000 divided by 1000 plus 1000. And that is going to be equal to 500 ohms. So let's erase these two. And we can draw in our 500 ohm resistor. Now on the other side, I notice the same thing. So I have these two. And these two are sharing the same potential on both sides. So I can calculate the total parallel resistance between the 500 and 750 ohm resistor. So this is going to be 500 times 750 divided by 500 plus 750. And this is going to be equal to 300. So let's go ahead and draw in our equivalent. So now that I've drawn in my equivalent, I see that these two are now in series. So I can add these two up and get a total value of 600 ohms. And we can erase these two and draw in our equivalent. And on the left-hand side, the 500 and the 100 are now in series. So this is going to be the same current for these two. And our equivalent resistor is going to be 500 plus 100, so that's going to be 600 again. So now our circuit looks like this. And at this point, we see that the 600 ohm resistors share the same two nodes. So that means that these two are going to be in parallel. So the equivalent resistance between these two is going to be 600 times 600 divided by 600 plus 600. And this is going to give you an equivalent resistance of 300 ohms. So this means that the total circuit simplifies to a single 300 ohm resistor.